Dear students, those of you who are taking the 10th and the 12th exam for the first time, all the best from my side. Work hard, study hard, and study without proper plan. Don't be afraid of the exams. Be confident. Understand your strong and weak points and study with a lot of confidence and dedication. I'm sure you will do well in your exams. Our teachers have made a beautiful PPT about the ways with tips how to face the exams. I would request all of you to go through that and prepare your exams and face it with a lot of confidence. Thank you.
How are you all? And NCERT exams are around the corner and not even 1 month is left. We are about to write the first exam as physics year this year, and this small video is about how to go about with the preparation for physics. Okay, and you see, always aim for 100% scoring and do not leave even a single chapter or single concept, and go thoroughly and solve problems. In physics, the major thing about scoring 100% or even 80% depends on how many problems or how many questions you read and solve. Okay, but here from the point of view of self preparation, how to go about, that is what we are going to discuss in this video. And first we will look at the breakups in the mark and the breakups in the way they ask the questions from the chapters. First, to begin with, physics is actually divided into 5 major sections. The section 1, the chapters 1, 2 and 3. From these 3 chapters, they will be asking 16 marks. Okay, and the next is, this is electrostatics and electricity, current electricity. And the next section is the next 4 chapters, which is moving charges, magnetism and electromagnetic induction and alternating current. From these, they'll be asking about 17 marks. Okay, and the next section is actually about optics, waves and optics, electromagnetic waves, ray optics and optical instruments, and then the last one is actually wave optics. So from these 3 chapters alone, they'll be asking about 18 marks. And the 4th section is, or you call it the 3 modern physics, we say, that is chapter 10, 11 and 12. From these 3 chapters, this is dual nature of matter and radiation, atomic physics and then nuclear physics, atoms and nuclei. From these 3 chapters, they'll be asking about 12 marks. And the last one, single chapter, which is the 14th chapter, semiconductor devices, and they'll be asking about, from this one chapter alone, they'll be asking about 7 marks. Okay, and in these 16, 17, 18, 12 and 7 marks, what is it? The proportion of knowledge based and then application based and then even the higher order thinking skills. Okay, the first one is basic knowledge, basic remembering, let's say the unit of certain physical quantity, etc. They'll talk about this, and then simple application of that formula is called remembering and understanding, and they'll be asking about 27. So this 27 mark scoring is literally easy. So for that, if you go through all the chapters and basic things, if you remember, you will be able to answer this 27 marks. And the next level comes simple application. This simple application bears about 22 marks. This 22 marks, scoring about 17 to 18 marks is very easy, but still I'm assuming that suppose you are able to score, attend only 13 marks. Okay, this itself puts us 40 marks. And the higher order thinking skills, they will be asking about 21 marks, which is slightly difficult from your point of view, but if you know the concept and if you have thoroughly understood the concept and solved a few problems based on it, even this section is going to be easy. Okay, and that is 21 marks. Assuming that you can score only 5 or 6 out of this, scoring 45 marks plus including the practical, you score about 75% in physics without any difficulty. In order to score 100%, you have to be thorough with all the chapters, all the concepts, and that 100%, let us say, even if you feel 100% is difficult, this 75% is very easy in physics. In fact, within the first 30 to 40 minutes, you'll be able to score literally 30 marks based on this simple remembering, understanding, and the simple basic application. You will be able to score that 25 marks very easily. So you should be ideally getting around additional of 30 to 45 minutes, because you will be able to finish the paper well before that. This is the kind of thing that you're going to write in physics. So suppose if you are afraid of it, so how to go about our preparation? That's what I'm going to discuss about. Okay, so our preparation should go from here like this. Let us say here, first always go with the 14th chapter, which is the easiest one simple chapter, and you go in this order. First go and finish 14th chapter, and then finish the next modern physics part, and then here you finish electromagnetic waves, and then wave optics, and then you go for ray optics, and in ray optics a few things which I will be discussing in detail later in this part of the video. And then you can go for current electricity, and then you can here go for magnetism, and then alternating current, and then you go for electromagnetic induction or moving charges, and that is how we should go about. So first is this, and then second is this, and third is this part. So we will discuss about each part in detail right now, and then you go for this one, and then you go for this one. If because you are at home, you are primarily depending on, let's say, self-study here, and you have to go from here to here, here to here, here to here. This way it boosts our confidence, because you can finish this. So the moment you start finishing things, and it really boosts our confidence, so that our ability to understand and then picking up the momentum, everything is easy if you go in this order. So that's what we are going to discuss about now. So how to go about and what kind of questions, and we need to focus on the 14th chapter. In this 14th chapter, and there are 3-4 parts. One is the initial things. They'll discuss about let's say semiconductors, what are semiconductors, and remember the values of resistivity, examples of organic semiconductors, inorganic semiconductors, those things. And then the second theory is band theory. So in this band theory, and try to remember what is valence band, what is conduction band, what is Fermi energy level, and then in fact donor level, acceptor level. So they have given the diagrams for that, and then you remember those values particularly, because in the last few years directly they have asked questions from there. And then the third major important part is PN junction diode. After semiconductors, N type and P type semiconductor, PN junction diode. The diode characteristics, and then diode thing. What kind of a question they might be asking in the PN junction? Let's say they will ask whether this is, even these are some kind of what representative questions, not necessarily these questions exactly will come. Let us say they will ask whether this is forward bias or reverse bias. This is 15 volt, this is 5 volt, whether this is forward or reverse. Usually from the positive point it is plus, and it is minus, and from here you try to subtract this from this. If the answer is positive, then it is forward bias. If the answer is negative, it is reverse bias. Sometimes they will ask like this is 0, or they will mention it as a ground, and this is -5. And if you look at this is 0, which is greater than -5, hence this is forward bias, like that. Otherwise in the application part they will ask like this. So here they will connect one resistor of 2 ohm, and then here they will connect a diode like this, and the resistor of 3 ohm, and what is the current in the circuit? That is one type of question they might ask. Suppose this is 6 volt battery, and this is connected like this. Since this is positive, and this is positive, and this diode is forward bias, this diode is reverse bias, hence this will not be in connections, only this circuit is completed, and hence in this 3 ohm resistor is not in the circuit, only 2 ohm resistor, hence the current through the circuit I is equal to 6 volt by 2 ohms, which is 3 ampere. So this is one type of question they might ask. And the characteristics, and half wave rectifier or full wave rectifier is there at the end of it, and you go through it. That is one. And try to read and study Zener breakdown and avalanche breakdown, the two breakdown mechanisms of p-n junction diode, and that is what is there in 14th chapter. If you spend one full day, or let us say half a day, you could actually finish this 14th chapter, which will really boost your confidence. The next comes the modern physics part 11, 12 and 13. So in these three chapters they'll be asking about 12 marks, right? So here what needs to be focused. So first let us look at nuclear physics. In this nuclear physics, what kind of things that you need to look at first. So first look at the nuclear characteristics, and then the nuclear force, and then whether the density of the nucleus, and then the radius. So density of a nucleus is whether the atomic number is 10 or 100 or 200. Density of the nucleus is constant, and they will be asking. So sometimes the questions will be like, what is the ratio of the nuclear density of hydrogen to aluminum? So what they will be thinking, so hydrogen 1 they will give, aluminum they will be giving like aluminum which is 27. So when you give, we might be thinking the radius thing, but both the nuclei have the same nuclear density. That is one part of a question. The second part in this comes and mass defect and binding energy per nucleon curve. So those three things needs to be learnt very thoroughly. And here from mass defect and then the binding energy, they will be asking application based question. Sometime we know that one atomic mass units energy equivalent is 931.5 million electron volt. This is mass and this is energy. So energy is mass by velocity square, hence usually they will give by c square. Sometimes they will give the mass defect in atomic mass unit, and you just have to multiply this to get the binding energy, and that is one. And then they will give mass of hydrogen and mass of neutron, and then let's say from this, and then mass of any nucleus X. So from this they will ask you to calculate. So in the nucleus mass number and then the atomic number given, so you just multiply the number of protons in the atomic number times mass of hydrogen, and atomic number minus mass times the mass of neutron. From the total mass, if you subtract this, you will get mass defect, and then you multiply this and you will get binding energy. If you divide by A, you will get binding energy per nucleon. And another important type they will ask is the binding energy per nucleon for deuterium is, let us say, some simple value I am giving 2 million electron volt. So two things combined to give you helium, whose binding energy per nucleon is 4.4 million electron volt. Means when these two combine to form this, what is the amount of energy released, they might be asking. So here binding energy is 2, here it is 4.4 per nucleon. So excess of 2.4 is there, and the total of 4 is there. 4 times 2.4 million electron volt is the energy released in this nuclear reaction. So this needs to be studied. And then alpha, beta and gamma decay will be there, only qualitative and theoretical aspect, and there is no problem in that. And in alpha decay, what is the atomic number, by what amount atomic number changes. In beta decay, how it changes, why the mass number does not change. All those things you study. And then the last of which, the next part of the nuclear physics is that proton cycle is given at the last thing, and you study without fail. This time there is a higher probability of asking that, so proton cycle, you learn it. Then comes this whole part of atoms. So atoms, a lot of things there, and you study very clearly and thoroughly what are there in atoms. In atoms, a very essential point is Bohr's theory, postulate, Rutherford, and then scattering cross section. All those things you learn. Then after that, when you go for Bohr's theory, just don't go with the derivation given in the textbook, and try to work out the radius of the electron in the nth orbit is it is n square by z times 0.53 angstrom. If you remember, along with the atomic number and the orbit number, you will, if the question asked is, once they have asked a question, what is the radius of the helium nucleus on third orbit of helium nucleus. So helium means z must be to n is third orbit, something like that. And also here they will be asking, what is the radius of the first excited state of hydrogen atom. Usually electron will be in the first orbit. If it first excited state means it goes to the second orbit. Instead of giving n is equal to 2, they will be giving you first excited state. Second excited state means n is equal to 3. And then without fail, work out the velocity of the electron in the nth orbit, which is z by n times 2.16 into 10 power 6 meter per second. And then time period of the electron in the nth orbit is z square by n cube times it is 6.58 into or 6.6 into 10 power 15 hertz, and energy of the electron in the nth orbit without fail it is z square by n square into minus 13.6 electron volt. Here if they ask what is the first excited energy of helium, in that case z is equal to 2, n is equal to 2, and then here this is the thing, first excited state means it goes to the second one. These are things they might be asking probably in the Bohr's theory. And then comes after this comes wave number. Find the study the definition of wave number, and then the angular wave number. It is equal to r into 1 by n inner orbit square minus 1 by n outer orbit square. Then Lyman series, Balmer, Paschen, bracket, Fund series. For that first member means for Lyman series first member means for Lyman n inner orbit is always 1, outer orbit starts from 2. So those things you remember, and application based questions can be asked from this part and then this part. So they might ask, and here in nuclear physics, as I said, application part question might come from this. And then the last is here this part, dual nature of matter and radiation. Also in atomic physics without fail, this one is there, de Broglie theory. So de Broglie theory, what they will be asking here is n lambda is equal to 2 pi into r. The circumference of the orbit is equal to n, quantum number of the orbit into lambda. Suppose wavelength in the second orbit will be equal to 2 times lambda in the second orbit equal to 2 pi into radius of the second orbit. So what is the wavelength of the electron ratio? They might be asking the ratio. So it is 4. Suppose fourth orbit means 4 times wavelength of the electron in the fourth orbit is equal to 2 pi into r4. Like that we have to take ratios. So these are application part comes in atomic physics. And then the dual nature of matter and radiation. In dual nature of matter and radiation, so here first the basic part is laws of photoelectric emission. How photoelectric emission proves it is, how photoelectric emission proves light is a particle and light is emitted in the form of energy packets. Those things is a qualitative part. And then the problem part comes in equations like photoelectric equation. Incident energy minus the work function is equal to this, h nu naught is equal to work function, nu naught is threshold frequency equal to kinetic energy of the electron, which is half m v square. This can be written as E into V. Based on this whole part will be there. Also the energy of the radiation. Energy of the radiation is equal to h nu, which is nothing but hc by lambda. Hc is actually 1242 electron volt nanometer by lambda. If they give wavelength and then they ask energy of the wavelength, you can use this. Or if they ask wavelength and given the energy, it is 1242 electron volt nanometer by lambda. You try to remember these two. Even if they give you frequency, use this relation, frequency into wavelength is equal to velocity of light. From that you can calculate easily lambda is equal to velocity of light 3 into 10 power 8 divided by the frequency given. You can get lambda, then you substitute the lambda and then substitute the lambda here and get energy, etc. So this is the kind asked in this. And then in this chapter without fail the graph. So what is it? Photoelectric current versus voltage when the intensity of radiation is same, and then when the different intensities are there, and also say different wavelength but same intensity, this graph. And then using this relation you can just have this particular part. So the stopping frequency versus stopping potential. So this will have greater work function, this will have lesser work function, those graph. Especially in nuclear physics also, here in nuclear physics also there is this nuclear force versus this distance graph is there, can learn that graph. So when you complete the 14th chapter, 11, 12 and 13, and literally it is about 19 to 20, 19 marks guaranteed, close to 20 marks you have got, and you have got, it will really boost your confidence and you can easily learn. And then comes the optics part. The optics part, how to go about it, this is very important. And here it is 8, 9 and 10. So this optic part, this is wave optics, this is ray optics, and then this is electromagnetic waves. Here how to go about it. If you go in wave optics, first you see Huygens principle, and then wavefront, and then what is the secondary source, what is the new wavefront. So all those things you learn in this, and then using Huygens principle, reflection and refraction, all those things you learn. So there is a diagram with that, so you learn that. Then comes Young's double slit experiment, interference. In interference, the intensity of the interference pattern. So you have the resultant intensity is equal to intensity 1 plus intensity 2 plus 2 root over intensity 1 intensity 2 into cos phi. So using this there will be problems. If both the slits have the same intensity, means I1 is equal to I2 is equal to I0 you can keep. So that becomes this is 2 I0 plus 2 I0, cos phi will be there. If you take 2 I0 out, it is 1 plus cos phi, it is 2 cos square phi by 2, and then 4 I0 cos square phi by 2. So this is the intensity of the central maximum, and here the phase difference. Using this phase difference to path difference, suppose if wavelength is lambda, phase difference will be 2 pi radian. If the distance traveled by the second wave is x, then the phase difference is phi. When you divide these two, lambda by x is equal to 2 pi by phi. If lambda and the x value is given, path difference given, lambda given, means you can find the phase difference as phi is equal to x by lambda into 2 pi. And if they give you this path difference, phase difference, if in order to calculate path difference is equal to lambda divided by 2 pi times the phase difference. If this is given, you can calculate this. If this is given, you can calculate this. This is one type of question from Young's double slit experiment. And then the next type of question is this fringe width. Fringe width is actually lambda d divided by d. Distance between this source and the screen, and the distance between the sources. Based on this, there will be questions. And it is slightly indirectly from here. For example, refractive index is frequency into lambda. Okay, velocity in, we can say here, velocity in vacuum divided by velocity in medium, velocity of light in medium. Velocity in vacuum is frequency into lambda in vacuum. Velocity in medium is frequency into lambda in medium, because the frequency does not change when light travels from one medium to another medium. Hence, the refractive index is lambda in vacuum divided by lambda in medium. Lambda in medium. Using this, they might connect this to here, because if the Young's double slit apparatus immersed in a liquid, then what is the what is the fringe width inside the liquid? So fringe width inside the liquid is lambda in the medium, in the liquid, into d divided by d. When you divide this by this, you will get fringe width in liquid divided by fringe width in vacuum is lambda L divided by lambda, which is the reciprocal of this 1 by mu. Hence, the fringe width in the liquid is equal to fringe width in air divided by refractive index. Hence, here the refractive index, fringe width is inversely proportional to refractive index. Hence, when Young's double slit apparatus is immersed in a liquid, the fringe width decreases. So here is where you get application level problem, here is where you get application level problem, and here reflection, refraction, they might ask the direct proof of this. So it is from basic understanding you might be getting. And here in ray optics, you need to have a strategy. First, in ray optics, here lenses, mirrors, etc. will be given. Lens maker formula, lens maker's formula, etc. will be there. As a second part, prism, optical instrument, and then total internal reflection. Mostly in 5 marks, either or this, even though this cannot be guaranteed, either from this part they will ask or from this part. So if you learn this part, you'll be able to answer at least 5 marks from this. In wave optics, when you learn this, you can literally score some decent score like 4 or 5, and in this part alone we'll be able to score a decent of 4 to 5 marks just by learning prism, optical instrument, and total internal reflection. Even though this cannot be guaranteed, we might expect mostly like this. In prism, in order to solve problems in prism, you just need this Snell's law, mu1 sin theta 1 is equal to mu2 sin theta 2. Once there was a question like this, there is a prism and light enters like this, then what is the angle through which it comes out of the prism? That is the question. So here what you can do is, when light ray comes normal to this, incident angle is 0, hence first refracted angle is also 0. So in order to learn prism, we know that A is equal to R1 plus R2, and then A plus delta is equal to I1 plus I2, and then you know that refractive index is equal to sine of A plus delta by 2 by sine A by 2. Using this, they will be asking question from the prism. And here you see, if it is an equilateral prism, then what is the second incident angle? And here you might have to apply Snell's law, because light comes from inside to outside, so it is mu times sine of the incident angle. If R1 is 0, R2 is equal to A, they said it is an equilateral prism, then angle of the prism is A, then mu1 sine 60 degree equal to mu2, it is coming out, hence it is here, refractive index is 1 into sine of this angle, the emergent angle E. So from this you can say E is equal to sine inverse of mu whatever value given and sine theta, and mu times sine 60 degree, or if they might give this as 45 degree or 30 degree or whatever, so you can use that. So in order to solve prisms, you need to focus on this Snell's law. Using that only you can. Also, you will have some basic problems in total internal reflection, because mu into sine of critical angle is 1, and which means that critical angle is sine inverse of 1 by mu. Based on that, there will be questions. And then optical instruments, simple microscope, compound microscope, telescope, and all that, and then total internal reflection. If you learn this part first, and then you go for electromagnetic wave. In electromagnetic wave, the questions will be like this. Let us say, in electromagnetic wave, you get first the 4 Maxwell's equation. So Maxwell's equation for electricity, Maxwell's equation for magnetism, and then E dot dl, B dot dl, all those 4 Maxwell's equation you do remember, and then calculating the displacement current is equal to mu naught epsilon naught into rate of change of electric flux, and this is an important thing. Then after that, there will be radio waves, microwaves, and then infrared, visible, ultraviolet, X-rays, and gamma rays. So the properties of all these things will be there. So learn that. If you learn these two, it gives a sense of completion of this chapter. Then it will be really very easy for you to move ahead. So right now it is around 18 marks from this chapter, from these 3 sections, from these 3 chapters actually. So 18 plus already some 20 marks we have completed, so 37-38 marks guaranteed in this. So if you just go through all this, it gives a complete thing. Then comes here, we have finished section 1 of 14th chapter, and then 11, 12 and 13 of modern physics, and then 8, 9, 10 of optics. So this whole bunch, literally except for this, it is second volume, it is mostly self-study. So easy for self-study at home without help. But the crucial thing in success is here, go through a lot of previous year question paper, read the questions by yourself, and even though you don't need to solve, you at least see the solutions for those questions and see how they have solved. So this bunch will boost your confidence really. And then if you go for the first volume, the first volume chapters are 1, 2 and 3, and then 4, 5, 6 and 7. This here, if you look at this chapter, alternating current, if you see only resistor, only inductor, only capacitor, and then the power factor and all those things will be there. Here it is both understanding type will be there in the inductor part, and then in the resistor, inductor, capacitor, and then LCR circuit, all those things might get some direct questions. In inductor part, if you connect an inductor to a DC, the inductor acts as a resistance. If you connect an inductor in AC, in this resistance will also be there, inductance will be there. Hence, this inductor connected in AC will act as both resistor as well as inductor. So R you can find from this, and then L they have given from that you can find out the impedance, etc. Here the the resistance, and then the inductive reactance you can find out, or the total impedance you can find. This is in this. And here mostly you go for this fifth chapter, magnetism and matter, with lots of things deleted in this magnetism and matter, and it's almost a theory part. From that directly questions will be there. In magnetism or in electrostatics and all this, there is a higher possibility of asking the dimensions. If they ask dimensions, the dimensions of energy is m L square T power minus 2, and then dimensions of force is actually m L T power minus 2. Using this you can literally find, suppose you don't need to remember the dimensions of magnetic field, because we know that force by a magnetic force acting on a wire carrying current in a magnetic field is force equal to BIL sin theta. Sin theta does not have dimension. Then the magnetic field dimension is equal to force divided by current into length. So the force dimension is m L T power minus 2. Current itself is a fundamental quantity, length is L, and then you can easily find out the dimensions of magnetic field. Similarly, if you want to find out the dimensions of capacitance or something, we know that energy is actually half CV square. We know V being work done per unit charge, or energy by charge. Charge is nothing but current into time. That you can substitute. Energy dimension and this energy dimension this IT is there, so you can find out the dimensions of capacitance. Even in electromagnetic wave, here this important formula you need to remember: velocity of light in vacuum is mu naught epsilon naught. You can find out the dimensions of this. So velocity on the left hand side, velocity is there, so dimensions of 1 by root over mu naught epsilon naught is length by time. So if they ask mu naught epsilon naught, so cross multiply, so mu naught epsilon naught is actually 1 by c square, hence its dimension is equal to 1 by L square T power minus 2, then it is L power minus 2 T power 2, like that. This kind of dimensions will be asked. And if you, after this magnetism, you can go for electromagnetic induction, because in this electromagnetic induction some basic things like change in flux, and then EMF induced is equal to d phi by dt, and then self inductance, mutual inductance, phi is equal to Li, then L is equal to phi by I. So self inductance or is nothing but the flux linked when 1 ampere current is flowing through the coil, etc. So those things will be there in this. And then after that, without fail, you go through transformers. So what is the input output power? So transformer, ideal transformer, input power is equal to output power, all those things. And here, after finishing this, if you come here, first learn current electricity, which is easy for you, and then learn some basic derivations from this, and then you go for the second part. So that way you can prepare these 4. So slowly, once you finish this bunch, second volume bunch with electromagnetic waves in the first volume, after finishing this bunch with the confidence gained if you go in this order, like first alternating current and maybe current electricity. This you can choose in any order, but go for these chapters specifically first. This alternating current, and then the magnetism, and then the current electricity, and then you go for first chapter, and then you go for fourth chapter or sixth chapter, and then you go for second chapter. In this way if you go, it will be really very easy. So the success lies on learning through questions. Like, read a lot of questions. So most important thing, read questions and solve problems. So these are two simple things. Read as many questions as possible, and see the solutions, how they answer the question. So most of the questions won't be direct, because this time they have made it very clear that competency based questions will be there. So if you go in this order, for the self study, it is a best order. Also here you first go for things which are easy and learn thoroughly, complete and write and practice, and then you go for the other things. It will be really very easy for you. All the very best, children. Scoring 100% is not difficult in physics, but it is least happening. So remember, nearly 20 marks, you can finish it in first, you can literally finish it in first half an hour. So to that extent, the 20 marks question answers will be easy. So scoring about 55 marks out of 70 is not a big deal in physics, which translates into 85%. So here what you need to know is, usually we might be afraid of that. See, it is always the fear of unknown, because you haven't touched certain pages. It might look difficult, but actually when you slowly, and you just need to have patience and read, and then you can easily answer. And in optics also, in wave optics, I forgot to add another point in wave optics, which is Malus law. The Malus law is actually I naught cos square theta, and then polarization, and see, restricting electric field vibrations to one direction is called polarization. And then these are some direct questions from Malus law. Some basic application type questions will be asked. So this is how you just should prepare, and actually saying it is very easy. Scoring 85% is very easy in NCERT exams. All the very best, children, all the very best. So learn well, and you just have to, without any prejudice, you just have to go through each and everything. That is the art. See, it is because you haven't touched. Sometimes it might give you a fear of, okay, there will be so much in physics. Not like that.
Dear students, I hope this video finds you in great spirits. You are prepared as you are in public examination. I wanted to take a moment to extend my heartfelt wishes to you. You have put in the hard work and dedication, and I have no doubt that you are well prepared to showcase your knowledge and skills. Keep a positive mindset, trust in your abilities, and don't forget to take care of yourself during this time. Get plenty of rest, stay hydrated, and take breaks as needed. A clear mind will save you well for exams. I believe in you, and you are born to win. All the best.